For question number 6, let's again talk through this. We're trying to prove that triangle ABC. So this one, ABC, is congruent to triangle CDA. And all you know is parallel lines. Well, parallel lines are not congruent lines, so that doesn't really help us. But the one thing you know about parallel lines is that if we have parallel lines, that's a way to give us congruent angles. So in fact, if AB is parallel to CD, what we can notice is that angle 3 then is going to be congruent to angle 2 because they are alternate interior angles. Here's our transversal, parallel, transversal, parallel. These are definitely alternate interior angles, and since the lines are parallel, those alternate interior angles are congruent. That's good because those happen to be angles in the triangles that we're interested in. The other thing we know is that BC is parallel to AD, and here's a transversal again. So if we go parallel line, transversal, parallel line, look at what we're outlining. Angle 1 then is going to be congruent to angle 4. So just by this little fact, right, so our first statement is our given. You have to write it out. Our second statement is going to be that angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3, and you definitely know the reason for that if you have parallel lines, then you know that alternate interior angles are congruent. Well, so now we have two angles. We just need, we need a side. And in fact, we need an included side, and that we have because of that old reflexive property. But we still have to state it. We have to state AC is congruent to itself so that we have the three pieces that we need. So that we have an angle, we have a side, and an angle. Again, in each triangle, we have two angles and an included side, the side that's sandwiched right between those angles. So therefore, we have enough information to say that our triangles are congruent, and our reason is angle, side, angle.